password on this computer. Visual Studio Code.
Yeah. Oh, there we go. Just type code.
Code. Oh, code will get me there. Otherwise, that's going to open up my virtual machine. Nailed it. I'm going to learn how to use these things.
Spotlight.
No, these computers. All right.
All you need is bin.
Yeah.
Such a crazy
Once upon a time.
There you go.
Now they've hacked it because I mean now you can actually push up. Well, I mean Vim's even newer. I mean the original VI, like you couldn't push up arrows and stuff. You know, now you can move around in there, but before you used to have to just do everything through keyboard shortcuts to jump up lines and stuff. Where is my? Why don't I have downloads in that folder? I'll figure it out. Well, it should be under my user's name here. I don't even see Dropbox on. Oh, I'm in my. Well, no, it should be over here. My downloads. I was looking over here. All right, whatever. All right, so there's my repos. I created a repo for our 450 torrent. All right, so initial goal is I have this picture called Cambria JPEG. So this is roughly what the new Facebook or Meta VR headset's going to look like. So I figured to use that as our image. So as a starting point, what we want to do is we want to read this image in a byte at a time and then write this image out a byte at a time, all locally, proving that we can make a copy of an image. Good starting point, because we've already done a whole bunch of stuff with child processes and threads and things like that. So really the change here is, can we read in bytes and can we write out bytes? Fair enough? All right, so, and I'm going to show you a couple of tricks in here that you maybe hadn't seen before. All right, so this is just all the code that just makes a duplicate of the file. All right, so I'm going to mess with a couple of different things here. I think I had told you as a hint in the homework that you should look at the data input streams, data output streams. All right, so we're going to be reading in from a file. The name of my file is called Cambria.jpg. So this guy does throw some exceptions and stuff like that. Now I actually am going to use exception handling here for a real purpose. Sign of the apocalypse. All right. And actually, this might have been where some of you got maybe hung up. So I'm creating my variables first. That way I have access to them inside the catch. So here at the beginning, I'm going to go ahead and create an instance of a file input stream. And this is going to go to my local file, Cambria.jpg. Then I'm going to wrap that guy in a data input stream so I can read it in 1 byte at a time. You could actually just use the file input stream if you want and read in raw data, but a data input stream will allow you to grab it 1 byte at a time, and it'll throw the exception when it tries to grab a byte and there's nothing else left. Then I'm going to create a file output stream with my destination being this file called Cambria copy. All right, because I want to read a byte in from the source file and write a byte out to the other file, and just do that a whole bunch of times until I've made a duplicate of the file. Okay. And then I'll wrap that guy in a data output stream, which again lets me write bytes conveniently instead of writing raw non-padded bytes. All right, so then I'm going to do something forever with the expectation that somewhere in here, when I go to read in a byte, it's finally going to say no more bytes to read, and an exception is going to occur. And that's what's going to actually kick me out of this while loop. So I'm gonna read a byte in from my data input stream into this variable B. I didn't have to put it in the variable B. I could have just read it in directly here. And then I'm gonna write the byte out to my data output stream. Just gonna do that over and over and over and over again until an exception occurs. As soon as that exception occurs, that exception is going to be an end of file exception, this EOF exception. And you can see that if you go into, was it data input stream Java, and you go to read byte. Is it under read that it hits EOF? I know, but that wasn't oh, so it throws both an IO exception and an EOF exception. I was just looking up here. It throws an IO exception, but it throws two different types of IO exceptions. That's for read fully, but it's going to be down there for read as well. There's your read byte. So this guy throws an EOF exception if the input stream has reached the end. So as soon as we've finished reading in bytes, we have an end of file. I'm going to go ahead and let the try catch system bail me out of there. All right. And then these other guys were just the other random IO exception stuff that can happen. Really, I could even just take this guy out if I wanted to and just say, well, I only care about EOF exceptions. Otherwise, it's one of these other ones that I'm dealing with the same way. But an interesting thing that maybe some of you hadn't messed with before is with a single try, you can have multiple catches. Okay, so you can decide, okay, I'm going to do this. I'm also going to do something else and things like that. So in this code up here, a whole bunch of different bad things could happen, and I can deal with those things separately by having different catches. Make some sense? All right, but all I'm going to do here is when I hit an EOF exception, I'm just going to print out end of file. But
like this one's very specific, but the exception is not. It goes to EOF exceptions. It's that.
Yeah, it goes to the one that it's that if it's specifically an EOF, it'll go in here. If it's just any old exception, it'll go here. If it's specifically an IO exception, it'll go in here. But it won't go into an EOF exception and then drip down through these other ones, even though an EOF exception is an exception. It won't hit both. All right, so that should be all the code needed to duplicate a file locally. Make some sense? All right, so let's go run that. Here's my terminal. I'll compile that guy. Now when I run it, I should just get a new file out of this. So I get my end of file. That was my proof that my exception got hit. Now I have this Cambria copy dealy flippy thingy. I should be able to double click on it and there's a file. Looks just like the original one. All right, so we've copied, we've read in bytes and wrote bytes locally on this machine. All right, questions about any of that? Not too horrible. Now, so was this the hard part of the assignment? Reading and writing bytes? Okay, so tell me what the hard part was.
Writing the byte. Well, wait, hold on. I think the problem for me with writing the bytes, it was this, but it wasn't. You're not doing it locally. You need to send the bytes from one client to the other.
Okay.
For me, it was from the client.
Okay. But isn't an input stream an input stream and an output stream is an output stream? Okay. Well, so. All right. So then for the, this is going to be our We'll just make this guy our server. All right, so here, let me just comment this junk out for a skosh. All right, so we want to go ahead and have our driver be our server listening for incoming connections, right? So that's going to be our server socket dude. So we'll do something like a system.out. Well, say while true, we're going to do some stuff. And we're going to go ahead and create a socket server socket. Nailed it. So we'll call this guy, let's say connection. This is going to be a new server socket. We give it a port number. What do we use before? 2222. All right, as good as any. All right. Who? Well, I think there's probably multiple versions of this guy. There's one that just takes port. Yeah, this should be okay. Yeah, he's screaming right now because he throws an exception that I'm not dealing with. Yeah. All right. Yeah, in fact, it wouldn't make sense for server socket to have a local host or anything like that. A normal socket, it would, because you're opening up a connection to a destination, which is IP address plus port. That's how you zero in on the, we had that discussion about process IDs and those dudes. All right, so we want to get our incoming connection. So we'll have socket client is equal to, what is it, connection.accept. All right, so this guy blocks until we, is this guy not happy? Not a type. Oh, I probably have to import Java dot. Oh, there. Now it's a type. All right, I just imported the whole Java.network library, so it won't scream at me anymore. So as soon this guy blocks, as soon as a connection comes in, I get that client socket. So now what I want to do is I could do this a couple different ways. I think in the homework assignment, I asked you to make a decision, like have the connecting client say what mode are they the one sharing a file, or are they the one sending a file? Or are they one retrieving a file, right? Which mode are they going to be in? Let's go ahead and do this in a do I want to do this in its own thread? Yeah, that'll be more fun. So let's go ahead and create a thread to handle all children. It'll just have two separate modes, kind of like our fork, where we say if it's one thing, do this. If it's something else, do something else. Let me hide the floating meeting controls. All right, so we're going to call this guy torrent thread.java. And this guy is going to extend thread. All right, at the very least, he's going to keep track of a client socket. Why doesn't it just add it for me? There we go. All right, I'll make my constructor for this guy. So public torrent thread. This guy will take in a socket, client socket. We'll set this dot client socket equal to client socket. We're going to probably piece out some other stuff in there too in a moment. But for right now, let's just make sure our threads spin up the way they should spin up. All right, then we'll have our public void run. Because remember, that's the method that we have to overwrite in or override, whatever it is, in for threads, to say when you start a thread, this is the dude that starts doing things. So we'll just do like a system.out.println child thread started. Okay. And we're not actually using the client socket now, but this will be good enough to get the ball rolling. So that's all our torrent thread's going to do. All right, so what we'll go ahead and do here is we're going to, once we have a connected thing, we'll create a torrent thread. TT is equal to a new torrent thread, passing it our client. And then we'll tell our torrent thread to start. All right, so now we should be able to start our server and have multiple clients connect at once. Let's just test that real quick. It should be fine. Java driver.java. All right, so that guy is sitting there listening for incoming things. So we'll tell that to localhost 2222. Oh, it's not. It's, you guys spell telnet better. All right, so that guy connected. This guy has the child thread started. Then we'll do another telnet localhost 2222. Okay, got child threads connecting. Everything seems to be fine. All right. So now what we need to do is establish some communication where we want the clients, and really we probably are going to go ahead and write a client application to talk to this rather than using telnet, because we're going to need to have access to the client reading bytes and writing bytes locally. So we're not going to have the opportunity here of rewriting telnet. So we are going to need a client application. So let's go ahead and write that. How do I create a new file? Ah. All right, we'll call this guy. I really want there to be a folder, maybe. Inside the folder, I'll have my driver.java for the client. Let's call it client driver. Otherwise, we're just gonna, well, I say we, I'm gonna get confused. So I'll call that client driver. And he's gonna have our public static void main in it. All right, so what he wants to do is he's going to go ahead and open up a socket connection to the running server, which that's the one that is the local host with the port. So we'll do our usual throws exception because we're lazy. We'll do a socket. S is equal to a new socket. And we're going to give this guy a local host and all right, that should be good enough for the moment to replace our telnet as much as it was before. Let's go ahead and just test that. Get our server spun back up here. We'll cd into our client folder. We'll compile that guy. Java client driver. Could not find or load. Client driver. No class def found. Did I save it? This guy's called client driver. He's in our client folder. Oh, it shouldn't. That's not how it works. I compile it. When you're using the Java virtual machine, you just call the class name. Yeah, call the client driver. Client driver has a main in it. Just as a I think that might be misspelled. Repos torrent, I'm in the client folder. Just out of curiosity. What? Not find or load main class client driver. Public static void main string array args. That's a thing. What if I hit play in here? Yeah, you seem to be happy with it there. Max. All right. What we're going to do is we're going to kill that tab. We're going to kill this tab because they're not friendly to us. We're going to start new tabs. CD downloads. Oh, I'm already in that folder. Client. Oh, because it's in the, why isn't it a package called client? Don't start messing with, that's the problem. Never growl at your computer. Client. It was, well. All right, there we go. Okay. So let's get that guy back out of there. Go back to our socket, make sure our server is still running. Let's just make sure these dudes will connect to our, so we should get a client connection here. Child thread started. And we'll do the same thing in here. Should get a second. All right, threads are starting. Everybody's happy. All right. So now, what do we do inside of our, where's the thread? Torrent thread. So inside of here, we want to start a conversation with a connected client, right? So we're going to need to be able to write stuff out to the client. We need to be able to read stuff in from the client, just like we did before. So we read stuff in using a scanner. It's what we've historically done, right? I'm going to amend that a little bit, say when we read text in, we're going to use a scanner. When we read bytes in, we're going to use a data input stream, just like we did a few minutes ago, but we're just going to wrap the data input stream around the input stream associated with the socket. All right, so I'm going to go ahead and we could do it all on constructor if we want. I'm going to say private scanner text input. So inside here, we'll go ahead and say text input is equal to a new scanner. And this is going to come from client socket dot get input stream. It won't matter here because it's a local variable here and it's a local variable here and it got set right here. So it's not wrong either way. When I say client socket dot get input stream here, I am talking about this guy will resolve to the dude right here. But you could pick your poison if you like this in it. Probably it doesn't have to be, but it should be. because all variables resolve to the most local definition. So it'll check here first, won't find it, then it'll check up here. But you're right. I prefer to put this dot in front of those guys. What am I doing? All right, this guy throws an exception. Let's be friendly and we'll just deal with it right here. So we're not passing the buck to main. Then we'll just catch our exception E and do nothing. Okay. So we'll go ahead and get our scanner. That's for reading in text. Now we want to be able to write out text. So we're going to do a private, what we use, a print stream. Text output. So this dot text output is equal to a new print stream. And this guy's going to be built with this dot client socket dot get output stream. All right, so now we have our text inputs and outputs. We know we're going to need our file stuff, but let's just leave it like this for right now. We'll add the stuff in as we need it. All right, so down here in run, we'll leave the child thread started here so we know the connection happened. So what we want to do is we want to write out to the child asking the question. Do you want to send a file or receive a file? Something along those lines. So we're going to say this dot text output dot println. Do you want to send or receive a file? This is on the thread. So as soon as the server gets the connection, we spin up a thread and we're going to have the thread communicate with the client to decide, are you sending or receiving? Otherwise, what we have is if you do that the server has to wait to finish having that discussion with the client before you can listen for the next guy coming in. Probably not a problem in our current example, since we're just going to have two clients talking to each other. But maybe if you want to have multiple, as where we're going with this, obviously your homework for Thursday is have a fully working BitTorrent. Which he's not going to do anyways. But at least, it's the enemy, he told me. Then it would matter, because at that point, we're probably going to want to deal with a singleton for storing what files are currently available for download, yada, yada, yada. Go ahead.
One of the things that's been throwing me off about all of this client server stuff is like where things get connected to. So because he's on the server, it's just created on the server, system.out.println
to the monitor on the server. Yep.
And then this text output will print it to the client.
Correct. Yeah. And that's why I named it specifically text. Well, yeah. I could have named it like text client socket output or something if I wanted to be real explicit. But yeah, that guy was built using the sockets input and output stream. So anything I read or write from there is flying over the internet or wherever that other program that connected to it is. All right, so do you want to send or receive a file? Then we're going to go ahead and read in the answer. This dot text input. Is it next line or just next? All right. This will block. Yep. And then we can start asking. So we'll say if answer dot equals, here we'll just assume that we're going to say the word send, or we're going to say the word and I'll be explicit here in case we decide to add some more commands in later. feel like I'm going to be error prone with the word receive. Yeah, I did here. Is it an I before E except after C? And then you do the little. You didn't do the dance after that? I still say it in my head. They drill it into you when you're kids. Like when I was in elementary school, that's like when they still beat you. Teachers running me down the hall, slapping me with sticks. I was a discipline problem. In kindergarten, they used to make me sit under the chair when I got in trouble. That's when I fit under the chair. What's up? No, they hadn't invented duct tape yet. They had duct tape. I assume they had duct tape, but no. But man, I remember that first grade teacher. Mad Dog Mullinex. She spanked me 3 times in first grade. I probably had it coming 2 of the times. All right, so we'll just print out receive file. All right, so server's going to write out asking the client a question. Client's going to read in from the server, so we need to make sure we sync these dudes up. So here's our client driver. We need to go ahead and build our same type of thing here around the client. So we're going to need a way to read from that socket. So we'll need to read text. Did I happen to name it S in here? Big money, big money. Oh, no, I didn't. Whatever. All right, so we're going to say scanner. Text input is equal to a new scanner built using s.get input stream. And then we're going to have print stream. Text output is equal to a new print stream. I got some extra parentheses here. S.get output stream. All right, and none of those throw exceptions? Oh, they do, because I just threw the exception. Good old, keep it old fashioned. Okay, so the first thing I'm going to do is the server is going to ask me a question, so I need to read in the question. So string question is equal to text input dot next line. All right, then I'll do a system.out.print whatever that question is. Now I'm going to read in from the client. So actually, to read in from my client, I need a local read. So I need a scanner for reading from the socket. I need a scanner for reading from the client. So I need a second scanner here. Scanner local input is equal to a new scanner built around system.in. That's the keyboard, right? So now to read in from the client, because I've just written out a question that I read from the server to read out to the client, read in from the client, I'm going to say local input dot next line. And that's going to be whatever the client's answer is. And right now that answer has to be send or receive because we said so. We're just assuming that on the other side. So make sure you spell it right or whatever. So we read in the answer, then we're going to send that answer back to the server thread. So we'll say text output dot println answer, and the server should receive it. And depending on what we said in there, if we received a send, we're going to say, okay, you're going to be the sender. Otherwise, we said receive, you're going to be receiving a file. All right. So let's just get to that point. I think all those guys are good. So let's pile the driver, run it. Let's start a client. All right, do you want to send or receive? I'll say send. Server should be spitting out that, okay, he's going to be sending a file. We'll connect again over here. Do you want to send or receive? We'll say receive. Server should be saying he's going to receive a file. If we connect again and we just type in whatever, server's not going to say anything. Try a thread starter, child thread starter, but we're not doing anything. And that's because we explicitly said, if you told me send, do this. If you told me receive, do this. Otherwise, I'm not doing anything. All right, questions up to that point. We understanding how all that, when we're communicating over the socket versus when we're communicating locally. All right, so now if this client has said that we're going to be the sender, that means they have to now set themselves up for the person who's reading in from their local file and writing out those bytes. And we wrote that stuff here inside of driver. So we're going to have our file input stream, our data input stream to read in from a local file. And then we're going to have our data out. Well, actually, we're going to have our data output stream to write over the socket. Okay. So if we're the sender, we're going to need a file input stream. Let's see, I'm on the client, I'm on the server thread here. So for this guy, I won't need the file output stream or file input stream. Only on the client do I need that. So if answer dot equals send, maybe we could ask him what's the name of the file. But for right now, we'll just write in Cambria.jpg. You could always ask them what file do you want to send. All right, so now we're going to need a file input stream here. File input stream, and this is going to be around file name. All right, then we're going to need our data input stream. This is going to be a new data input stream around fizz. All right, so now we're going to be reading stuff in. So we'll do our while true. We'll add some more stuff here in a second. It's a while true. We want to read in a byte. I'll just do the same thing we did before. Byte B is equal to dis.read byte. All right, now we want to be able to send that byte over the socket using a data output stream. So data output stream, DOS, is equal to a new data output stream. And this is going to go with our our socket, s.get output stream. So we're using that output stream again, but this one for data output instead of text-based output. You could pull it off either way, but this will make clean bytes be sent over the internet. All right, so we're going to write a data output stream now over the internet back. So what do we do here? We'll say dos.write byte B. So we're going to write our data output stream, which is linked to our sockets output stream, and we'll write that byte. Now we happen to know, we'll just go ahead and throw all this inside of a try catch. We happen to know that all this stuff finally dies when we get that EOF. So catch EOF exception. So that means that we have finished sending the file. So the client was right out to their screen, I'm done sending the file, whatever. And then they can disconnect, I guess. We're not having them do anything else right now. This is as far as the client server thing is going right now. All right, so if we're in send mode, read in a file, write it out over the socket in bytes, 1 byte at a time, finally die when we finish reading in stuff. When this guy read byte finally runs out of stuff to read, we've already written all of them across the output stream, and then we should be done. Good.
Why do we write byte to give it
It's a reasonable question. In Java, there's no reason why it can't take in a byte value. I wonder when it's reading something from a file, it could be something with how data input stream it is implemented, where it reads in padded values. Why would it read in more than 8 bits though if it's reading in a byte? I don't have a great answer. I mean, they're the same underlying data type, being that they're both integer data types, but really needs to be it needs to be an unsigned byte. Yeah, interesting question. I'm sure there's a legitimate reason, and it's probably related to some old C library, would be my guess, is how it was originally written. All right, so this is what the client does if the answer was send. He's gonna send stuff to the server. So here we can go ahead and write the catch side of that. But we would probably we can do one more. Let's just write it first. So we'll say sending file here. So now that means the client we're connected to is going to be sending us stuff. So we're going to need a data input stream. And this guy is going to be a, you know what, I'm going to, well, whatever, we'll move it if we need to move it. So this guy is going to be this dot client socket dot get input stream. All right. And then we're going to read stuff in as long as we can read stuff in. So we're going to say byte B is equal to this dot read byte. All right. Now we're going to be writing this byte someplace else. Ultimately, we're going to write this byte out to the client. Okay. We don't have that side yet. We're going to be writing it out to the other client. This is the me client. So I kind of need to store this file locally if I want, or at least keep track of the bytes, or have a list of clients in a singleton or something like that. But that's the situation with this guy. I have to do something with this because I can keep writing them in, but now it's what am I going to do with this? I guess for right now, let's just do a system.out.print B. So we'll just do a byte dump to the screen so we see data flowing in until we go to write it out kind of better. And then we're going to, this guy is going to possibly, so let's see, can I convert an input stream to a data input stream? Oh, this is a new data input stream built around that dude. Okay, and we're going to try to do all this stuff. All right, and then we're going to catch. It's going to be interesting to see what the catch will be because we're going to keep reading bytes, but eventually we're not going to be able to read more bytes from that. So is that going to hit an end of file? I don't think so because he will. That is actually coming from the underlying input stream for file input stream they were working with before. So this might give us an IO exception. We'll just print that stack trace out to see what error we get from that guy. All right, so if the client says they're going to send, the server says we're going to be in sending file mode. Well, actually, what we should probably say is we're going to say we're receiving a file from the client. That's what we're actually doing here. This one is we're going to be sending a file to the client. That's what we're actually accomplishing there. All right, so we'll get our input stream, then we'll just start reading in bytes from the client until the client doesn't give us any more bytes. We'll have to see if we get an IO exception from there, but we'll see that here in a second. So that's all this thread should do is receive a byte, spit it out to the screen. So we'll just get a whole bunch of numbers on the screen. So then from the client driver perspective, he's just going to start reading stuff in and writing it to our sockets output stream forever and ever and ever until he finishes sending it. All right, so let's see what this ends up looking like. We do need to make sure, since it's our client sending the file, we need to make sure he has that local file. So this Cambria JPEG, I'm going to go ahead and copy this and put it into the client folder. I'll get rid of both of these guys from here. All right, because there's going to be that client who reads in his local file and then sends it over the socket. And then the socket's going to receive it and just spit it to the screen right now. All right, server is up and running. Client, you want to send or receive, we're going to say we're going to send a file. Says we finished sending the file. Client got a whole bunch of crap. All right. Oh, good. So we did get an EOF exception. It did that final byte that it read. So just from a debugging perspective, I suspected we're going to get some sort of problem at the end there. I wanted to see what that problem was. So what did I do? I went ahead on the thread. I just caught some kind of IO exception. This guy was going to be something with IO reading from a socket. And I just printed out whatever it was. So this just told me the thing to look for when it's done. It is an end of file exception when it's done reading it. Okay. So we could actually say we're going to catch an EOF exception. And we can do like a system.out.println done receiving file, something like that. What's this guy upset about right now? Oh, because he also throws the IO exception. So since we saw earlier when we looked at read byte throws both an IO exception potentially, as well as an EOF exception. So in order for him to be happy here, I need to deal with both of those. even though I don't intend to deal with this IO exception. I'm only interested in that EOF exception. All right, so let's make sure these guys line up now. So we'll kill off the server, recompile it, rerun it. We didn't actually change the client, but say we're going to send. Let's finish sending the file. This guy received a bunch of stuff, and then we said done receiving the file. All right. So now the server could use his exact same code that he has right now to send the to write the file locally. We already wrote that code today, right? To just save a file locally. So we can already copy it from a client who's running anywhere on the planet who has a local file. He can send it to the server and the server can write it locally. Make sense? We could write it here, but we already wrote that code today. If you receive all the bytes and you write them locally, you got a copy of the file. All right. But what we want to do here is when we have a connected client that wants to be the recipient, he's going to receive the file that we presumably read from someplace else. Go ahead.
We did something really weird, like that when I copy the bytes, but it just be like the correction over that.
Well, it would probably be some level of data corruption, but only for the reason of a JPEG has an internal format. So probably like the lead-in bytes for a JPEG are going to be like a special thing. So you'd be feeding it the wrong lead-in bytes. But if you at least had the right, like, hi, I'm a JPEG lead-in bytes, and then you just garbled the rest of it, I mean, you would just get an interesting image, I guess, because those bytes are typically for a JPEG are going to be like RGB colors or something like that, or hex values. Okay, so now we have to solve the problem of, well, so any questions up to this point? You get what's kind of going down? So now we have to solve the problem. If I'm the client and I tell the server, oh, I want to receive a file. Well, how do we do that? Because who has that file? Because now we're back to inter-process communication, inter-thread communication, right? Because I have one child thread at the server who's reading crap in from a connected client. I have another child thread on the server who's preparing to write stuff out to another connected client that these guys might be in different parts of the planet, right? So how does the two threads find out about each other so that we can write the bytes out to the right place? All right, make some sense? All right, so maybe a singleton. So why don't we go ahead and do something like this? Is this the right place? And I want to have this in just the server side of things. What am I doing? Is it down here? Up here. That's the client driver. Where's this driver? Oh, that's where I got confused. Okay. So I just want it in this folder down here. The core, the server folder needs to have that singleton. So I'm going to create a core.java guy here. So we're going to have a collection of, this is similar to what we did with our chat server. So whenever we have somebody interested in receiving files, they need to somehow get loaded up onto core so that they can be in the broadcast bytes array type thing, right? So we're going to do like a private static array list, even though they're not thread safe, but whatever. And we want to write out to these guys. So we're going to have these guys be data output streams. This will be a new array list of data output streams. All right. data. Oh, I need to give this the client DOS, the client data output streams. Yeah, perfect. All right. So then maybe we create a synchronized method for a broadcast byte, something like that. So we make this guy public. Synchronized. Static. What else are you going to be? Let's call this guy broadcast byte. And this guy will take a byte B as a parameter. And then what we're going to do is we're going to go through our array list, presumably for a whole bunch of connected clients, right? Go through our array list. So we'll say for data output stream DOS in core dot the client DOS dot write byte B. Yeah, I need a public void. More better. Nailed it. These are probably out of order. All right, this guy throw an exception of some kind. Yep. So we'll just say, try all this stuff. Just catch any old exception E. Dot print stack trace. All right, so in our singleton on the server, whenever we have somebody who comes in wanting to be a recipient of bytes, we're going to go ahead and add that person to this array of data output streams so that we can just start sending bytes out to whoever's connected. This does presume they're all connected and waiting before our one sender arrives, but that's okay for our example right here. So over on the meeting controls. So now over on our torrent thread, if we're going to be receiving, then what we want to do is we want to add that client to our core thing, and we actually need to write the ability to add it to our core thing. Public static or public synchronized static void add DOS. It's going to be a data output stream DOS, and we'll say core dot the client DOS is add DOS. All right, so now we can add a guy to our array list. So over in our torrent thread, we'll go ahead and say core dot add a new data output stream built using the client socket. So we're going to send this guy a new data output stream from this dot client socket dot get output stream. Right, and bad stuff can happen in here, so we'll just throw all this in a try catch. Who? Do I? No. Oh, I do. Extra special data output stream. Super duper. There. And then we'll have our catch. Whatever. Stack trace. All right, so if we're a receiver, we're just going to go ahead and we're going to add ourselves to the DOS here and wait to have things be broadcast to us. So we probably need to have this thread actually sit and wait. So we'd have to go and look up how threads wait. We can do a secondary thread and just have this guy try to like sit and wait to read something in. That'll make him block if we wanted to do that. Otherwise, actually we have the pointer to the guy, so it might actually be okay for this thread to just die. I think it actually would be okay for the thread to just die. The socket is a local value on this thread, but I have a data output stream built out of that socket. So will this socket actually die if I have his output stream being used someplace else? I'm guessing probably. So we don't want this guy to die. Okay. So then on our client driver, well, actually we can do it up here. For our server, our send, instead of just outputting to the screen, we're going to say core broadcast byte B. So we'll broadcast the byte to every interested client. Make sense? All right, now if we're on our client driver and we're the else to the send, I'll be explicit again. Answer dot equals receive, something like that. Then we receive the bytes and write to a local file. All right, and once we write this, we should be able to share a file anywhere in the world between two clients. We're going to be having it be local here, but that doesn't matter. Okay. So no homework for Thursday. I think we should still meet on Thursday so we can finish up this guy. And of course, I'll give you an impossible assignment over Easter. All right, sound good? And you didn't even have to negotiate. I thought you were threatened to not do it, or you wouldn't be able to bring yourself to do that. See, look, he doesn't want to disappoint Littman. All right. Well, good luck with your Professor Blade assignment. But hopefully this stuff makes a little more sense now after going through some of it. No, you don't get this. This is gold. All right, hold on. Well, you were just begging for it. You're crying some. It was pathetic. All right. 50 torrents. Make it public. All right. I'm not going to give you something over Easter. Oh. I'm a jerk, but I'm not that bad. Like somewhere in here, there's like this decent guy. You just got to get used to the kind of the rough edges.
Oh, I think I'm already used to rough edges. I just have a lack of motivation.
Yeah. Why?
I have
But you're not graduating yet.
graduated this semester.
Next semester.
Yeah.
Yeah. So senioritis comes as you're the final weeks of you're almost about to graduate. That's when you just shut down and slide into home and hope you didn't fail everything.
I'm just ready to wake up in the morning and go to work.
I get it. I get it. All right. I put it up on Slack. All right. So wasn't that torrent stuff fun?